Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 8, that is the arrays. This is the module, that is the second module, which I've covered or which I'm covering is the procedural programming module. So this is the second module, right? So in the last class we have talked about the array, introduction to the array and the single dimension of the array. That is what is array and how array will be used. In the today's class I'm going to start with the two-dimensional array, that is how two-dimensional array will be used. So in the last class we have discussed about this till this part. Today I'm going to start with the two-dimensional array. But before this, let's take a quick review what we have covered in the last class, that is the basics of the array and the single dimension of the array or the single dimensional array. So let's start with the concept. So first of all, what comes in our mind? Array. Array is a collection of homogeneous data types. Homogeneous means similar data type. Means whenever we use the similar data type, whenever we combine multiple similar data type like int of 5 types, that is int of 5 types, that is the int takes 5 types, that is a array. It means collection of similar data types. Suppose I have taken 5 variables of the integer types, that is an array. So it's an array, right? So in C language, array is a collection of similar data type. For example, if I have to declare 5 variable that is of array type like int a, int b, int c, int d. Yeah, I remember that question, last question, but Larry, you have to write down again the question because question is not in my notepad, not in my book, nothing. So please write the question again and I will answer the question at the end of the session, right? So array is a collection of similar data type, that is we can collect the similar data type like int, float, char. That is if I combine char of the 5 types, that is a char 5, that is a character 5, that is a array of the character, that is a char array that contains 5 integers or the 5 characters. So this is the array. So the C language provides a capability that enables the user to design a set of similar data type that is known as the array. We note that in many C books and course, array and pointers are taught separately, but in this book it is going to be taught individually. Individually means that in combination. Why? Because it is very effective if I taught array and the pointers along with. So what are the arrays? No doubt this is the example that we have discussed. So an array is a collective name that is given to a group of smaller quantity. So what is an array? It is a collection of similar data type. That is the collective name that is given to a group of similar quantities. Similar quantity means all are of int types, all are of float types, all are of character types. That is it is a collective name that is given to a group of similar quantities. These similar quantities could be percentage marks of 100 students, salaries of 300 employees or age of 50 employees, either 100 students, 300 employees or the 50 employees. What is important is that the quantities must be similar. Similar means of same type, either int, either char, either float. This is the example, either using char, either using float, either using double. This is percentage 3, that is the percentage is an array variable that contains 3 values. Yeah, one more thing that we have discussed in the last class, that in array the element numbering, that is the index numbering, always starts from the 0. That is the first element will be stored at the 0 location, then 1 location, 2, 3, 4 till what we want to store. Suppose there are 10 elements, so the first element will be stored at the 0 location, second at the first location, third at the second location, and so on till 9th location. So an array is a collection of similar elements. This similar element could be of int, float or char, etc. Usually the array of characters is known as string. As I told you, when we combine multiple characters, that becomes a string. So an array of character becomes the string. This is a program that we have discussed. That is a simple program that is done by using the arrays. This is a simple program that uses the marks as an array that is stored, or that stores the 30 variable or 30 values. So it starts from the 0, it ends with the 29. So it is starting with the 0 and ends with the 29. That is from 0 to 29. Then there are two lines, that is printf and the scanf. Again, in this there are two lines, that is used for the printing purpose. This is used for entering or getting the data from the user. This is used for getting the sum from the, or reading the data from the array. Then uses the average, that is the average equals to sum divided by 30. That is the average is calculated by dividing the sum, or by taking the sum and divide by the 30, because average is what? If I combine or if I add all the values and divide it by the total number, that is the average. Then we will discuss about the array declaration, how array will be declared. This is the method how array will be declared. Here int specifies the type of the variable that is using. That is marks is the array that is of integer type that stores 30 values or 30 variables. Remember that this is a bracket that is used when we deal with the array. Then next topic that we have discussed is how to access the elements of an array. That is how to get, or how to access, or how to specify, or how to get the values from the array. That is the elements from the array. This says once an array is declared, let us see how individual elements in the array can be referred. This is done with the subscript, the number in the brackets following the array name. Therefore, marks2 is not the second element of the array but the third one. Why it is third one? Because it starts with the 0 and ending with the 2. So it is not the second, but it is the third one that is used. In our program, we are using the I as a subscript to refer to various elements of the array. Then next point is how to enter the data into an array. This is the way how we can enter, using the for loop. Then how to read the data we have discussed. This is the way how to read the data, again using the for loop. This is also using the printf for displaying the output. These are the various things that we have discussed about the array. So let's start with first one, that is array is a collection of similar data type or similar elements. The first element is numbered as 0. So the last element is 1 less than size of the array. So the last element that denotes always the 1 less than the size of the array. Suppose 30 is the size, so last element is stored at the 29th location. Next, an array is also known as subscripted variable. So array, another name for array is also known as subscripted variable. Next, before using an array, its type and dimension must be declared. That is, before using any array, or before using an array, its type and dimension must be declared. However, big an array, its element are always stored in the contiguous memory location. This is very important point, which we have discussed in detail later on. That is, how big an array, its elements are stored in the contiguous, means one by one or side by side memory location. That is, there is no space between the memory location. They are stored at the side by side memory locations. Then more on the array, how to initialize. This is the array initialization. We can initialize the array in these three ways, either giving the specifies a number, or simple uses the bracket, that is n number of number that is used. Then this is the float type, that is we can also declare the array that is of float type, that is taking the decimal numbers. And these are the points. Note the following point carefully. Then array elements in the memory, that is how to get the array elements in the memory. That takes 2 bytes for the 8 integers. Then bound checking we have discussed, that is how to check whether the array will be declared or not. There is no check to see if the subscript used for the array exceeds the size of the array. Data entered with the subscript exceeding the array size will simply be placed in the memory outside the array, probably on the top of the other data or on the program itself. Then next is how to we have discussed how to pass the array element to a function. that is how to pass the array element to a function, that is how one variable, that is the actual argument, will be passed that contains the array. This is the example. This is the function that is passing the array element. Till now we are passing the argument as an integer, float, that is a number, but in this the array elements are passed to a function. That is, this is the array element that is passed through a function, that is display marks I this. Then this is the definition of the display, that is this is the definition of the display function, that is the int m, then printf %d m, that is the m will be used as a or for printing purpose. This is the call by reference, that is the call by value, and this the value will be passed. This is the call by reference, that is the reference will be passed, that is the address will be passed. This is the example that we are passing the address, that is m% marks I. Then we will discuss about the pointers and the array, that is how pointer will be used within the array, or how pointer and array are combined or used with each other. We have discussed multiple arithmetic operations. These are the arithmetic operations of the pointer of the array. This example shows how address of the variable will be increased. If we are taking the int, that address will be increased by 2 bytes. If we are taking the float, that will be increased by 4 bytes. If char, that will be increased by 1 byte. The way a pointer can be incremented, it can also be decremented. This is the addition, this is the subtraction. This is the subtraction of one pointer from another pointer. This is the comparison of two pointer variable. That is, we can compare, we can add, we can subtract the pointer variable. This is the important part, that is a word of caution. Do not attempt the following operation on the pointer. That is, we cannot perform the addition of two pointers. We cannot perform the multiplication of a pointer with the constant. We cannot perform a division of a pointer with the constant. That is, addition of two pointers is not possible. Multiplication of a pointer with constant is not possible. At the end, division of a pointer with constant is also not possible. This is the example that we have discussed. This is again the example that we have discussed. Now, what we have also discussed, how to pass an entire array to a function. That is, how to pass the entire array. This is the entire array that is passed to a function. Now, let's start with the today's topic, that is the two-dimensional array. So this is what we have covered in the last class, and in the today's class I am going to start with the next topic, that is a two-dimensional array. That is how two-dimensional arrays are used. So till now we have covered about the single dimension array, that is only the one dimension. Now it is a time to explore the array, or it is also possible for the array that contains one or more dimensions. In simple terms, dimension means not specific to the single value, single row. We can also made in array 3 rows, 4 columns, 4 rows, 3 columns. Means any number of rows and any number of columns. Remember, horizontal lines are known as the rows and the vertical lines are known as the columns. This is, so far we have explored array with only one dimension. It is also possible for the array to have 2 or more dimensions. The two-dimensional array is known as matrix. So whenever we use the two-dimensional array, that array is known as the matrix. Remember, that array is known as matrix. Here is a simple example that stores roll number, marks obtained by the student side by side in a matrix. That is how this program shows how roll number and marks that is obtained by the student and the roll number are stored side by side in the matrix. So starting with the main function, there is a curly brace. Then take the integer as or array as an integer. That is the stud. Student is an array. Remember, this is the important thing. Student is an array that is of integer type that contains 4 rows. The first one This is the first square bracket that represents the rows, and the second bracket represents the columns. So this is the rows and this is the column. That is, student is the array that contains 4 rows and 2 columns. Then two variables are declared. One is I, one is j, and both are of integer type. Then uses the for loop. That is, start with the for loop. It starts with the 0. That is, I equals to 0, I is less than equals to 3, I plus plus. That is, it starts with a 0, then 1, then 2, then 3. Then there is a I plus plus. Then printf and scanf, two operations or the two lines are used. So in I, it starts with a 0 and it ends with the 3. That is, it runs for the 4 times. That is, enter the roll number and marks. 2% d are used. That is, 2% d means 2 types of integers are used. That is, there is a space. Then ampersand student I0. Now let us start take the meaning. First of all, I0, and this is also a 0. It is placed at the, or it is stored at the 0 0 location. Then 0 1, that is 0 1. Now I becomes 1. Why? Because the I plus plus. Now if I come here, student 1 0. 1 0 means first row, first column. This is 1 1, first row, first column. In the same way, this is also used for printing purpose. Yeah, let's see. There are two parts of the program. In the first part, through a for loop, we read the values of the roll number and the marks. That is, in this, the first block, we only read the roll number and the marks of the different students. Whereas in second loop, we print the values. Look at the scanf that is used in the first loop, right? In this and this, the first subscript of the variable stdu is the row number, which changes for every student. That is, if there is a row number 1, that's changed for every student. If there is a row number 2, that's changed with different student. The second subscript tells which of the two columns we are talking about. The 0th column, which indicates the roll number, or the first column, which indicates the marks. That is the 0 column. This is the 0 column that indicates the roll number, and the first column which indicates the marks. Remember, the counting of roll number or rows and column begin with 0. The complete arrangement is shown below. This is the row number 0 that is stored at the column number 0, that is the first one, that is the 0 location or the 0th column which contains the roll number, and the first column which contains the marks. This contains the roll number and this contains the marks. So this is roll number, this is marks. The roll number is 1 2 3 4 and the marks is 56. Next, the roll number is 1 2 1 2 and the marks is 33. Then 1 4 3 4, marks is 80. Then 1 3 1 2 and the marks is 78. So this is first column represents the roll number, then second column represents the marks. Thus 1 2 3 4 is stored at the 0 0. Why 0 0? Because there is row 0 and the column or the roll number 0. 56 is stored at the 0 1. Why? Because the row is 0 and the column is first. So this is 0, this is first, and so on. So this is the second, this is the 1 0. That is, first of all, 1 is taken place, that is the 1 is the row and the column is 0. Then 1 1, that is the first is the row and first is the column. That is the marks that obtained by the student. In fact, there are two-dimensional array. The above arrangement highlights the fact that a two-dimensional array is nothing but a collection of a number of one-dimensional array placed one below the other. That is, it is a collection of one-dimensional array that are placed one after the another. That is, if there are three numbers that are used, that is, we can place the 2 or 3 numbers side by side, one after the another or one below the other. In our sample program, the array elements have been stored row wise. That is, the array element will be stored in a row wise format, like this format, and accessed row wise. That is, this can also be accessed row wise. However, you can access the array element column wise as well. That is, we can also access the array elements column wise as well. So we can also use the row wise, we can also use the column wise format. Traditionally, the array elements are being stored and accessed row wise, therefore we should also stick to the same strategy. Now, how to initialize a two-dimensional array? That is, how or what is the method to initialize the two-dimensional array? Till now we discussed how to access and how to display. Now, how to represent or how to initialize a two-dimensional array? This is the way how we can initialize. As I told you, there are 4 rows. So this first one represents the rows, second one represents the column. This is 4 rows and 2 columns. So these are 4 rows and there are only 2 columns. 4 rows and 2 columns. Or even this would also work. This is the 4 rows and 2 columns. This is the first row, this is the second row, this is the third row, this is the fourth row. It is important to remember that while initializing a 2D array means 2 rows, 2 columns, it is necessary to mention the second column dimension, whereas the first row is optional. That is, it is mandatory to declare the dimensions in the 2D array. Therefore, the declaration, these are perfectly capable or acceptable. That is, we can or the column specification is mandatory and the second column or the second one dimension is very mandatory, that represents the column. In this there are 2 rows and there are 3 columns. So 2 rows and 3 columns, that numbers are represented by 12, 34, 23, 45, 56, 45. That is, this is the first row, this is the second row. There are 3 columns and 2 rows. Then array 3, that is there is no specification of the rows, but the columns are specified. This is also the same, this is also same. Whereas if I define the rows but we cannot specify the column, that cannot work, because column is very mandatory. Rows are any number of rows we can specify in C, but columns we must specify before we are going to start with the two-dimensional array. Next, memory map of the two-dimensional array. That is how memory mapping is done in the two-dimensional array. Let us reiterate the arrangement of array elements in a two-dimensional array of students, which contains the roll number in one column and the marks in the other. The same example. The above arrangement shown in figure 8.4 is only conceptually true. This is because the memory does not contain rows and the column. In memory, whether it is a two-dimensional or it is either one or two-dimensional, the array elements are stored in one continuous chain. The arrangement of array elements of a two-dimensional array in memory is shown below. That is, this is the dimension, this is the way how the array will be stored, or how address will be stored in the memory, that contains the rows and the column, and it's a two-dimensional array. This is at the 0, 0 location, that is the 0 and the 0. This is at the 0, 1 location, this is at the 1, 0, 1, 1, 2, 0, 2, 1. The 0, 0 means 0 row and the 0 column, that is the first point. In this there is a 0 row but the first column. Then there are 2 columns in every row, and this is first row and the second first column. This is the first row and the second column. Second column is represented by 1. This is second row and the first column, second row and the second column, third row and the first column, third row and the second column. Means there are 4 rows, 0, 1, 2, 3, and there are 2 columns only, that is 0 and the 1. Means every row contains only 2 columns. And this element is stored in the memory, that is 65508, 10, 12, 14. Why there is a difference of 2, 2? Because it is of integer type. We can easily refer to the marks obtained by third student using the subscript notation as shown below. This is example of the printf, that is marks of third student, that is equals to %t, that is stud, that is the student, to 1. That is 2 rows and there is a 1 column. Can we not refer to the same element using the pointer notation as we did in the one dimension? Answer is yes. We can use the pointer with the help of the or we can also use the pointer in the two-dimensional, that is a 2D arrays. So now let's start with the pointers with the 2D array, that is how pointers and 2D arrays are used. This says the C language embodies an unusual but powerful capabilities. It can treat parts of the array as an array. That is, it treats the part of the array is also an array. More specifically, each row of a two-dimensional array can be thought of a one-dimensional array. That is, every row in the two-dimensional array, that is, every row contains multiple parts, that contains the multiple one-dimensional array. This is very important fact if we wish to access array elements of a two-dimensional array using the pointers. This is a declaration part, that is a S52. So there are 5 rows and there are 2 columns. This can be thought of a setting of 5 elements, each of which is a one-dimensional array of 2 integers. That is, there are 5 rows, that is an array of 5 elements. Each row contains 2 columns, that contains one-dimensional array consisting of 2 integers. We refer to an array element of one-dimensional array using a single subscript. Similarly, we can imagine S to be an one-dimensional array, then we refer to it to the 0 S0, that is at the first location, then S1 and so on. That is, S0 gives the address of the 0th one-dimensional array, and S1 gives the address of first one-dimensional array, and so on. This fact can be demonstrated by the following program. That is the fact that is demonstrated by the following program. This is a demo. That is a 2D array is an array of array. That is, we can use the 2D array as an array of array. This is the example. In this there are 4 rows and 2 columns. The same example. Curly braces open, curly braces close. There is a semicolon, because this is the initialization of the array, initialization of a variable. So that will be terminated by semicolon. Then int I. So uses the for loop. Start with the 0, ending with the 3. So it is executing at the 4 times. Why it is executing at the 4 times? Because there are 4 rows. So first of all, it starts with the 0. So this is I0, then I1, then I2, I3. So there are 4 output that is given. That is the address of 0 at 1D array. That is a one-dimensional array. For example, this row will be stored at 0 location at the 65508. Then 65512. Then 16, then 20. Why there are gap of 4 integers? Because each row contains 2 elements, and every element contains or takes 2 bytes. So every row will be incremented by the 4. That is, every row address will be incremented by the 4 bytes, because that contains 2 variable, and these 2 variable contains or takes 2 to array. So this example takes the 2-dimensional example as well as the 1-dimensional. That is, at the every row there is a 1-dimensional element, that there are 2 elements that is of 1 dimension. So every row contains 4 bytes. Why? Because it takes 2 to each. Let us figure out how program works. The compiler knows that S is an array containing 4 one-dimensional array. This is an array that contains 4 one-dimensional array, that is 1, 2, 1, 2, 1, 2, 1, 2, each containing 2 integers. Each one-dimensional array occupies 4 bytes. That is, each one-dimensional array, this is the one-dimensional array, it takes 4 bytes. Why? Because the 2 bytes for each integer, as I told you. These one-dimensional array are placed linearly, that is a 1D array followed by the 1D array. So this is the 1D array, and this is the 1D array, and there are so many 1D array that is available in this one. Hence, each one-dimensional array starts 4 bytes further along than the last one. That can be seen in the memory map of the array that is shown below. This is the 0, 0, 0, 1, 1, 0, 1, 1. That is 0, 8, 1, 0, 1, 2, 1, 4, 1, 6. We know that the expression, this one and this one, would yield the address of the 0th and the first one-dimensional array respectively. From figure 8.6, these addresses turned out to be 65508 and the 65512. That is at the 0 location it is 65508 and then 65512, then 16, then 20 and so on. Now we have been able to reach out each one-dimensional array. What remains is to be able to refer to the individual elements of a one-dimensional array. Suppose we want to refer to the element that is S21 using the pointer. That is, suppose my requirement is that I have to use the pointer, that is the pointer S2 plus 1. We know from the above program that S2 would give the address 65516. That is the address of the second dimensional or second one-dimensional array. Obviously, this is the array that is used, that is the address, that is the plus 1 will give the address of the 65528. Why? When as I told you, when we add 1 to the address, it gives the, or it moves to the next location, that is the next location is after 2 bytes, that is 65518, or this is the, which gives the address 65518. Why? Well, this is the array, and at the 2 location, this is at the 2 location, this is the address, and if I plus 1 or add 1, that becomes 65518. And the value at this address can be obtained by using the address operator. That is, the address is done by using this, and if I want to get the value at this address, we can use the pointer variable. But we already studied that while running one-dimensional array, num I is same as the num plus I. That is, this is the same as this one. Similarly, S2 plus 1 is same as if I write pointer S2 plus 1. That is, the this num I will be represented by this one. In the same way, the sum 2 is represented by the S plus 2. This is the S plus 2. This whole is the S plus 2, and there is a plus 1, and there is a pointer that is used. Means this part will be replaced by only S2. So this S2 is equal to this part, and there is a plus and there is a S2 sign. Therefore, these are the same. This is the same, this is the same, this is the same. Using this concept, let us take the program that print each element of a two-dimensional array using the pointer notation. Right. So how to use the pointer notation in the array or in the two-dimensional array? So starting with the main function, declaring the variable, declaring the array as a S, and there are 4 rows and the 2 columns. So there are 4 rows that is used, and there are 2 columns that is used. That is, every row contains the 2 columns, or that is 2 elements, each of having the 1 dimension. Then uses 2 variable ij, starting with 0, ending with 3, that is 4 elements will be used. Then printf /n, that is the /n means move to the next line. Then starting with 0, using the j variable, starts with the 0 till j is less than equals to 1. That is at the 0 location and at the second location, that is the first location. That is, it executes for the 2 times. Why? Because every column contains 2 variables. Then j plus plus, then printf %d, this is asterisk s plus I plus j. That is, the si will be used as a pointer. First of all s0, then s1, then it will be incremented or added by the j variable. This is the output 1 2 3 4. First of all, there is an address and there is a marks. Next one marks, that is a 56. In the next row there is a 1 2 1 2 33 and so on. This is the output. Now pointer to an array, that is how we can pass the pointer or how we can use the pointer in an array. This says if we can have a pointer to an integer, a pointer to a float, a pointer to a char, then can we not have a pointer to an array? This is, we certainly can. That is, we can use or the array in the pointers in the array. This is example. This is the main function. This is int 52. That is, there are 5 rows and there are 2 columns. These are the 5 rows and there are 2 columns. Now this is not 52, this is 42. This is a mistake. Then this becomes a 4 because there are 4 rows and 2 columns, right? Then uses the pointer, that is p is an array variable, that is a pointer that is of integer type. So p2 is a pointer variable that stores some integer values. Then int ij, pointer pint, p int, that is three variables are or more used. One is I, one is j, one is pointer. Pint, that is a pointer integer, that is of integer pointer. Then uses the for loop, that is starts with a 0 and ending with the 3. So it starts with 0 and ending with 3. So it is 0, 1, 2, 3. So it starts with 0 and ending with 3. So there are 4 elements that is stored. Then uses p equals to ampersand si, that is using the variable, using the ampersand, that is stores the value, that stores the address, that is p is a pointer variable that stores the address of si. Then stores the p address into the pint, because pint is also a address variable pointer. Then printf, that is in the next line it will be printed. What is printed? That is address plus j. This is the output. First of all, this will be printed, that is the address, then there is a marks. Why? Because first of all it starts with a 0, that is the 0 location, then 0, 1, 0, 2, 0, 3. So here AP is a pointer to an array of 2 integers. So P is a pointer, that is an array of 2 integers. Note that the parentheses in the declaration of P are not necessary. That is the parenthesis in the declaration of P. This is the declaration of P is not mandatory. In this there is no mandatory of the declaration of P. Absence of them would make P as an array of 2 integer pointers. Array of pointers is covered in a later section in this chapter. In the outer for loop, each time we store the address of new dimension 1 array. Therefore, for the first time, though this loop P would not contain the address of the 0th, that is a 1D array. The address is assigned to the integer pointer, that is a pint. The same example, the same concept that we have studied. Now, next topic is how to pass the 2D array to a function. That is how to pass the 2D array that is available to a function. There are 3 ways in which we can pass the 2D array to a function. What are the 3 ways? These are illustrated in this one. That is how we can pass a 2D array to a function. That is how function will be used, or how array will be passed within a function variable. This is the main function, and this is the main part that will be starting the program. Then there is a int34, means there are 3 rows and there are 4 columns. Then this is the 3 rows and the 4 column concept. There are 3 rows, that is a 1, 2 and 3, and there are 4 columns, that is 1, 2, 3, 4. Then uses a clear screen. Yeah, this is the important part for you. This is the first time you see. This clear screen will clear the screen when we type any code in the Turbo C editor. There is some hodgepodge in the program, because once you execute one program, that output will be stored for the time being at the screen. In the same way, when you move to the next one, the timing will, or the output will also display on the screen. But when you use a clear screen, that is a CLR SCR, then the output will be cleared. That is the before output or the previous output will be cleared. That is a CLR SCR. Then uses the display function. What is the use of display function? That is A34. Then uses the show function, that is also using the variables as an actual argument, that is A34, A34, A34. Now uses the display function, that is use the display function first of all. So whenever the cursor moves to this one, this moves the cursor directly to this definition of the function. Now there is one pointer variable, that is q, one is an integer, that is row, one is an integer, that is a column. There are 2 variables that is used, that is ij. Then start with the 0, that is 2 loops are used. One is used for row, one is used for column. This is the most important part. And the another important part, you know that until and unless the inner loop will terminate, we cannot jump to the outer loop. That is, first of all the conditions of the inner loop will terminate, then only we move to the outer loop, that is the outer part. That is so there are 2 variables, that is the j, I and the j. So start with the for loop, that is I equals to 0, that is the I equal to 0. Then it ends with the row, that is the row that specifies the, or this is the specify, that is it is 3. So this is the row, that is 3. So it starts with 0 ending with 3. So there are 3 rows. It is less than 3. not ending with 3 but ending with 2. If it is equals to 3, equals to row, then it is 3, but now it is only 2, that is 0 1 2. Then I plus plus, then uses the curly braces, inner loop will be used, that is j equals to 0, j is less than column. Well, how many columns? That is 4. It is less than 4, so it starts with 0 and ending with 3. Not taken as a 4. Why? Because it is less than 4, not equals to less than equals to 4, right? Then j plus plus, then uses the printf statement for printing purpose, uses the percentage %t, uses the pointer. How pointer will be used? That is q plus I into column plus j. That is, this is one variable, then this is another variable, then this is another variable. Then uses the printf, then there is a curly brace, again uses the printf. So this curly brace will close the code for the inner loop, for this loop, and this curly brace will close the function only. So first of all, this will be executed until and unless this condition will never terminate with our cursor, our execution part, our pointer cannot move to the this part. So first of all, inner will terminate, then only move to the upper loop, that is the outer loop. Then there is again the show function, again using the ij, pointer p, less than row, less than column. The same concept, two loops are used, one is for the inner, one is for the outer. Then this is the next part or the last part. Last function is your print. The print function is used. The same concept, uses the array, not using the pointer but uses the array, row and the column. That uses the for loop, that is row, inner loop, that is a column. Now this is the output that is used. So first of all, 1 2 3 4, then 5 6 7 8 9 0 1 6. This is the first time, and the second time it will also display the same. Third time it will also display the same. Because why 3 times? Because it starts with the 0 and ending with the 2. So there are 3 times that is used. This is the example, or this is the explanation of this. This says, in the display function we have collected the base address of today array. That is, this is the display function. In this we have collected the base array of the everyone. This is the base array that is used of the today array being passed to the ordinary int pointer. Then though the for loop using the expression, that is pointer q plus I into column plus j, we have reached the appropriate element in the array. Suppose I is equals to 0 and j is equals to 3. That is, for example, let's take the I as a value 2 and the j as a value 3. Then we wish to reach the element, that is the 2 comma 3. That is at the 2 location, at the second row there is a third column. Let us see now this expression does give this element or not. This is the example. The expression, this one, becomes this one. Why? Because the q is 65502 first of all. Then I value is 2 because it is 2 3. Then next column is 4, then plus j, that is also 3. Now because why there are 4 columns? As I told you, there are 4 columns and 4 rows. Then this turns out to be 65502 plus 11, that is 4 into 3 plus 11. This is an address of the integer, so this is equals to this one, that turns to be 65524. Value at this address is 6. So this is the address that is used. This is indeed as shown in the as example, or as similar as the A23, that is 2 rows and 3 columns. A more general formula that is used for accessing each array element would be this one. Then uses the show function, we have defined q as in pointer of 4 variable through the declaration. So this is the explanation of this diagram, or of this example. Then next is array of pointers. The way there can be an array of int or array of double, we can also use the array of pointers. That is, more than one pointer are also declared, that is known as the array of pointers. that is when we declare more than one array, that is a array of, sorry, when we declare more than one pointer, that is an array of pointers. This says, since a pointer variable always contains an address, an array of pointer will be nothing but a collection of addresses. That is, when we collect the addresses, or when there is a collection of different addresses, that is a references, that is known as the array of pointers. So an array of pointer means a collection of different or similar addresses. The addresses present in the array of pointer can be address of the isolated variables or address of array elements or any other addresses. That may be any address, isolated variable address, but the condition is that that address must be of similar data type. Or rule that goes to the ordinary array applies to the array of pointer as well. What are the rules? The same rule: contain homogeneous data type, contain or stores the data in the proper format. I think a program would clarify the concept. So this is a program that clarifies the concept. This is the main function that is used. Then there is a curly brace. Then there is a array of integer pointer. That is, this is an array that is a pointer, or that is a pointer that takes 4 bytes. That is a array of integer pointers. So this is int pointer array 4, or ARR 4. That is, array is a pointer variable that is of integer type that takes 4 values. This is next variable will be declared as I as a 31, J as a 5, K as a 19, and the L as a 71, and there is a new variable that is a M. Then stored at the 0th location there is a percentage I. So at the 0th location the I will be stored, that is at the 0, this will be address of the I will be stored. In the same way at the first location, because it is 4, that is 0, 1, 2, 3, at the first array pointer stores the address of next, that is a J. Then the second array, or the second array location, it is storing the address of pointer K, and at the third array it will be storing the address of pointer, or storing the address of L. So these are the 4 arrays that will be used as a pointer, and these are the 4 addresses that will be stored. First of all, I address will be stored, then J, then K, then L. Then uses the for loop by taking the variable, for example M. This is also already declared. For M equals to 0, M is less than equals to 3. So it will be executing for the 4 times. Start with the 0, ending with the 3. So 0, 1, 2, 3. So it will execute, or it will be executed for the 4 times that is used. So first of all, when it is 0, that is the array 0. That is the first location, that is a pointer that will be printed. This is the array 0, so the address of I will be printed. Then address, this will be incremented, that is the M1, so array 1, this will be address of J will be printed. Then array 2, that is the address of K will be printed. Then array 3, that is the address of L will be printed. Then there is a closing of the curly brace. This says figure 8.8 shows the content and the arrangement of the array of pointer in the memory. That shows the arrangement of array of the pointers in the memory. As you can observe, ARR array contains the address of isolated int variable. That is, it stores the address of the int variable, that is isolated int variable, that is I, J, K, and L. So this is the example. Array contains the address of the isolated integer, that is ijkl. This is the ijkl, and the for loop in the program pick up the address present in the ARR and print the value present at that address. That is, it is used for printing purpose. This is the example, that is I contain 31. This is the 31. Suppose it has an address 65516. J has a value 5 that contains address this one. K19 that has this one. L71 that has address this one. And this is the array that will be used, that is array 0, array 1, array 2, array 3. So there are 4 arrays that will be used, that is storing the values. So in this array 0 there is an address, that is address of I. This is the address of I will be stored as a value. Then this is the important point. Then array 1, in the array 1 this is the address of the j, although but it's stored as a value, because for array 1 it is a value but has a different address. This is the address different, address different, address different, address different. So logically it is correct. Why? Because we are using the array as a variable, so we store any values, either it takes address, either it takes any value. It does not treat as a value or the address separately. No, if I store the address it will be accepted, but that address becomes a value right now, and that value have a separate address also. So in simple terms, address can have a address also. This is the best example. That is, next point says an array of pointer can even contains the address of another arrays. The program would justify this one. This is the pointer that is used, that is using the a plus 1, a plus 2, a plus 3, a plus 4, using the UUD, that is P pointer, pointer, P. I would leave it for you figure the output of this program. Now next category is the two-dimensional or three-dimensional array. So in the last class we have covered about the one-dimensional array. In today's class we have covered about the till now we have covered about the two-dimensional array, but now I am going to start with the next concept, that is a three-dimensional array. But before this, let's take a 5 to 10 minutes break and then come back, starting with this topic, that is a three-dimensional array. As the name advice, three-dimensional array means now there are 3 rows, there are 3 parts. One is row, one is column, one is again the column. That is 3 parts will be used. These are the 3 parts. That is, we can specify 1, we can specify 2, we can specify 3. Right. So let's take a break for 5 to 10 minutes, then come back starting with this topic, that is the three-dimensional array. Now let's start with the three-dimensional array. So come back from the break, starting with the next topic, that is the three-dimensional array. So till now we have discussed about the one-dimensional array and the two-dimensional array. So what is the difference between the 1 and the 2? First of all, in one dimension there are only the numbers that is given, like 1, 2, 3. That is, there is no row concept, there is no column concept. But in 2D array there are 2 concepts, there are 2 rows, 2 columns, row, column. In the same way there is a three-dimensional array. In this, that there are 3 rows, there are 4 columns, n number of columns, n number of rows. That is a 3, 4, 2, n number like. So let's start with the three-dimensional array. This is, we are not going to show a programming example that uses a three-dimensional array, because in practice one rarely uses the array. That is, there is no this is not common in practice that uses the three-dimensional array. But this is the exceptional case. In the exceptional case, it is the using the three-dimensional array. However, an example of initializing a three-dimensional will consolidate your understanding of the subscript. That is 342. This is the example. A three-dimensional. This is the example of 4 rows, 2 columns, 4 rows, 2 columns, 4 rows, 2 columns. Right. And three-dimensional array can be thought of an array of arrays. That is, an array of arrays means, and it is a combination of different arrays into one array. That is, combine the array of arrays. The outer array has 3 elements. This is the outer array that contains 3 elements. This is contains 3 elements. Each of which is a two-dimensional array of 4-dimensional arrays. That is, this is a one array that has a 4 dimensions. That is the 1, 1, 1, 1. Each of which contains the 2 integers. This contains 2 integers. So this is an array, means there is an array that contains 3 rows. So this is 1 row, this is 2nd row, this is 3rd row, right? And every row contains 4 elements. Means every row contains 4 rows. That is, this is the first row that contains 4 rows and 2 columns, right? Second row, this is this part that contains 4 rows, 2 columns. Then third one that contains 4 rows and 2 columns. So this is the array of arrays of array. That is a 3-dimensional array. This is the grammatical representation. This is a 2D array. This is a 2D array. This is a 2D array. 0, 1, 2. So That concept is over. That is a 2D array. Now there is a summary part. What is the summary part? First of all, it is saying an array is an ordinary variable except that it can store multiple elements of similar type. So array is nothing but an ordinary variable or a simple variable except that it can contain multiple values at the same time, multiple elements of the similar type. Compiler does not perform bound checking on an array. That is, it is not the responsibility of the compiler. That is, it is not in the authority of the compiler to perform the bound checking on an array. Next point says the array variable acts as a pointer to the 0th element of the array. In a 1D array, that is, if there is a 1D array, the 0 element is a single value, whereas in the 2D array, this element is a 1D array. That is, if we were using the 2D array, the 0 element is the first element of the, or one element of the 1D array. Then on incrementing a pointer, it points to the next location of its type. Then when we increment the pointer, that points to the next location of its type. That is next part of the type. Then array elements, next point says array elements can be stored or are stored in contiguous memory location, and so they can be accessed using pointer. That is, the array element are stored in a contiguous memory location, that is one after the another, and so they can be accessed using the pointers. So these are the last concept is that only limited arithmetic can be done on the pointers, like addition of two pointers cannot be performed, multiplication of a pointer with the constant cannot be performed, division of a pointer with the constant can also not be performed. So this is a summary. These are the various points that describe what we have covered in the chapter. So these are the 6 points that we have covered. This is the exercise. This is the exercise for the simple array. What is the output for this array? Then this is the pick out the errors from the program. Then this is the answer of the following. This is the important question. Wow. An array is a collection of different data type that are scattered through the memory, or an array is a collection of similar data type scattered throughout the memory, or an array is a collection of similar data type placed next to each other in memory, or different data type. Now your concept is clear. It is a collection of similar data type. So either you can opt this value or this option, or either you can opt this option. So let's take it is a collection of similar data type that are scattered throughout the memory or placed next to each other in the memory. As I told you, it is a collection of, or array is a collection of similar data type that are stored in a contiguous memory location. What is the meaning of contiguous? That is next to the next. That is the one after the another. So the option is C. Why? Because it is placed next to each other in the memory. Are the following array declaration correct? This is the answer question. Yeah, my question is to the OLSM. Yeah, OLSM. This is correct. Only OLSM will answer. OLSM, this is correct. Int 825. Yeah, OLSM. Are you able to hear me? My question is only for to you, that this option is correct or this declaration is correct or not. Okay, Larry, thanks a lot. Why not correct? Can you tell me, Larry? Okay, that's a square bracket. Yeah, that's a square bracket. So yeah, so this is not a correct declaration, right? Now my question is to the meaty Benjamin. Either this is a correct or not. My question is to the Larry, this question is only for the meaty Benjamin, not for you. Yeah, meaty Benjamin, are you able to hear me? This is correct or not? There is no response from the meaty Benjamin. Okay, Larry, you tell me, this is correct or not? Yeah. Okay. What about this one? What about second arrangement, second line? Here it is declared as a, yeah. Okay, okay, okay. Okay. What about this one? Thanks a lot, matey Benjamin. What about this one, Larry? Why? Because there is no square bracket that is used. There is a curly brace that is used, right? Okay, okay. Okay, thanks. Now, my question is to the meaty Benjamin only. This is true or false? The array int num26 has 26 elements. This is true or false? Only the first part. My question is only to the meaty Benjamin. It's correct or not? It is true or false? True. Can you tell me the reason why it's true? I can hear you. Can you describe why it is true? Okay, no, there is no response. Yeah, because there are, but this is a true. Why? Because there are 26 elements that we've stored. Because it is of num 26, that is starts with a 0 ending with 25. So there are total 26 elements that will be stored in the array. Now, tell me that, Larry, this is correct or not? This is why it's correct? But as I told you, the first, yeah, as I told you, the first element will be stored by the 0, not the 1. But it is 1. So this is not a correct, because the first element, as I told you, in array, the elements are always start with the 0, not the 1. So this says it designated the first element. No, it designated the second element. Why? The first element will be represented by the num 0. So it's a false. Got it? Okay. Okay, okay, thanks. Then next is, it is necessary to initialize the array at the time of declaration. That is, when we use the declaration, when we initialize the array, for example, array 5 equals to 1, 2, 3, 4, 5. So it is necessary to initialize at the time of array, at the time of declaration. No, it's not necessary. We can declare at the starting phase, we can declare at the declaration. We can declare at any time, but it is not mandatory to initialize the array at the time of declaration. Okay. Next question, fourth question is, the expression num27 designated the 28th element. And now, Olism, if you are able to hear me, then please answer this question. This is true or false? There is no response from the OLSM. Yeah, Michi, yeah, that's true. Why? Because this denotes the 28th element. Because it starts with the 0. Yeah, your answer is correct. Good. These are the various questions about the array, bubble sort, insertion sort. These are the array of the or the output on the arrays. These are various questions. Now pick out the error. This is also interesting. This is the question. Now this says pick out the errors if any. Now let's see. This is the array that will be declared as a 6 variable that starts with 1 ending with 6. So there are total 6 elements in this, right? Then there is a I that is declared as a variable. Now start with 0 ending with 25. So it starts with 0 ending with 25. So there are total 26 times it will be represented. Then I++. Then printf %t array I. So first of all, at the 0 location it will be printed. Second location it will be printed. Third location printed. Fourth printed. 5 printed. 6 printed. But what after the 6? There is no element. It means only 6 variables are declared over here. But we are using the 25 looping, that is from 0 to 25. So there is an error. What is the error? In this there is either 6 or either 5. If we are using the 6, so it starts from 0 ending with the 6. So there are total 7 elements. That is also not correct. So it is instead of 25 it is using the 5 because it starts with 0 and ending with 5. So there are total 6 elements that is stored. So what is the error? Instead of 25 it is used as a 5, right? Then Larry, my question is to you. What is the error in this? Please read it out carefully and tell me the error. If there is any error, if there is no error, tell me there is no error. My question is for Larry. It's correct. Why it's correct? My question is why it's correct? It's not. Uh-huh. Uh-huh. So it's not correct or correct? Why it's correct? As I told you, array always starts with the 0. But in this, the array starts with the 1. So this is not correct, Larry. As I told you again and again, the array always starts with the 0. But here it is 1. So it is not correct. Okay. Yeah, first is 0. That's the tricky questions. These are the questions that you have to practice by your own. Now Larry, tell me, what's your opinion about the class? It is going smoothly? You are fine about the class? Yeah, so okay, you find interesting class, right? There's no boring class. Yeah, okay, thanks a lot. Because what I think that if there is no interaction among the student and the teacher, so how it's interesting class? That's why I'm asking from you. If you're feeling bored or if you're feeling bored in any time in the class. So it's good if the class is interesting. Nice. And you are able to cope up or you are able to understand each and every concept. Okay, 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 good, keep it up. Now these are the various questions. This is also a pick out error. These questions you have to practice. Yeah, Meety, your suggestion is that I'm trying to catch up. You are lit behind. Yeah, I agree. Okay. Can you interact with the voice so that there is a proper interaction, there is no chatting process, if possible? No, it's okay. Yeah, tell me the question, Meety. I don't remember the question. Okay, no issues. Your headset is not working. It's okay. But tell me the question. What's the question? I didn't remember what's the question because there are so many students in which I've taught. So I'm confused among the students. Yeah, hi Matey Benchwin. I got your request. That means you want that I have to give some example with the help of Turbo C, right? Yeah, it's good. Means you want that I will show you with the practical approach, right? Okay, okay, no issues. But I agree with you, but this takes only 2 or 3 days because first of all I will download the Turbo C in my system, format it, and type the code. So this takes only 2 or 3 days. So give me the 2 or 3 days. I will show the code. It's my promise to you or to all of you. So give me 2 or 3 days. I will run the code. Okay, okay, it's okay. Yeah, I agree because this shows in a practical way. If you see the code, what is the code running, what is the output, what is the error. So it is very beneficial for you also. All right. So I will try it best for the 2 3 days and I will show the code. Right. Now come to the Larry question. It's the time for the Larry question. Larry, give me this question. This is the question for the Larry. The question is that from the example on the storage class, say auto storage class, main, there is a main function, there is a auto int equals to I, auto int equals to 2, auto int I equals to 3, then printf I, right? Then printf I, then printf I. The question is that 3 to 1. The control, why is the output 3 to 1 instead of 1 to 3? Could I read at the result of the pattern of braces? Yeah, this is the correct. That's, that is, first of all, the inner loop will terminate. That is, the inner curly brace will terminate. That then only goes to the outer curly braces. This means, first of all, this is attached to this one. So first of all, this will execute. Then only this will terminate. Then goes to the next part. This printf is used for the 2. Then print the 2 value. Then again terminate with this one. Then go to the next printf. This printf is used for the 1. Then the 1 will be printed. So in simple terms, first of all, inner curly brace will execute, then outer curly brace, then again outer curly brace. So this will work for the inner, outer, outer. That is from the bottom to the top. So output is 3 to 1, not 1 to 3. Right? Larry, you got my point? Okay, okay, thanks. Your next question is, you have 2 questions, na? Okay, 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 okay. Yeah, your next question is, I get some time when executing the program. A function should have a return time. You are using Turbo C++. Okay. Uh, so you are using void main or only main function? Okay. Instead of main function, you write int main, right? Int main at int main. Yeah. But at the end of the program, when the curly brace, the last curly brace, write the return 0. That is a return 0, and then terminate by the semicolon. Means at the starting phase, write int main. At the ending phase, when your program is finished, return, use or write return 0. So first of all, int main and then return 0. I will write it with the help of chat also, right? Means at the starting phase you write int main, and at the ending phase write return 0, and then terminate with the semicolon. I will write with the help of the, or I have written with the help of the chat also. That is the int main, right? Then there is a return 0. This is not main, this is spelling mistake. Return 0 and then terminated by the semicolon, right? Now your question is clear, Larry? Okay, welcome. Any other questions from anyone? Because it's important to discuss each and everything, because if I'm teaching each and everything and if you have a questions, then how it will be possible to write the questions or to solve the questions, right? So any other, if you have a questions, please ask the question, because today is the session for the question answer. I took this session first of all that no, there are so many questions of the student, so please took this session so that my session will be completed or questions will be completed. So if there are no questions, so let's move further. These are the various examples. This is also example. This is an example of the read write. Now let's discuss one or two questions again. This is the question, this is the example. What is the output? This is again the example. Now this is the question. In an array, int array 12, that is if I am declaring the array 12 as an integer type, the word ARR, that is an array, represents the what of the array. Means it represents subscript, it represents data type, or it represents name. So the output is it represents the name. Why? Because ARR is the name and the int is the data type and the 12 is the subscript. So ARR is the name of the array, right? Next point says, or next question says, what would happen if you put too few elements in an array when you initialize it? That is, when you initialize the array, you put few elements, and your requirement is that you should use 6 elements and you put only 4 elements. So what is the output, or what would happen? Nothing. Possible system malfunction, error message, unused element will be filled with the 0 garbage. So the correct output is, or correct answer is, error message that we came from the compiler. That is, there is an error that there are too few elements and here you are accessing beyond the element. That is the error message that came from the compiler. Then next point says, what would happen if you assigned a value to an element of an array whose subscript exceeds the size of the array? Now there is a reverse condition, that is the subscript means the array size will be exceeds the size of the array. So this will give the error message, take the data, so the output is the same, it takes the error message from the compiler. Next point says, when you pass an array as an argument to a function, what actually get passed? Means when you pass an array, what actually get passed? Address of the array, values, address of the first element, number of the elements of the array. So what is the pass, or what is the, when you pass an array, what actually get passed? The values of the elements of the array. So this is the answer is, second one is correct. When we pass the elements, or when we pass an array, what is the output, or what will be passed? That is passing the values of the elements of the array. And next, true or false. That is, next point says the address of a floating point variable is always a whole number. That is, the address that is given to a floating point variable is always a whole number? No, it's a decimal number. So this is not a correct point. But this says address of a floating point. Sometimes it may also be true, because we do not take the address as a whole decimal point. So the output is, or the answer is true. Why? Because address is always in a integer, always in a correct form, not in a decimal form. So the answer is true. But if this is written, the value of a floating point is always a whole number, that is not correct. Why? Because the value is always in a decimal form, that is in a point form, but the address is always in a whole number, that is a true. Right. And this is a program that you have to study, that you have to write, not study it. This is again the example. This is again the pick out error problems. This is again the questions that based on the programs. This is the next question. These are various questions about the array, because array is one of the important topic in the C language. Now that chapter is over, now let's move to the next topic, that is the chapter number 9, purporting on the string. That is, the purporting means going on to the string, or control over to the string, or move to the string. That is the next topic, but there is no time left. It's 5:50 around the IST, so there are only 5 minutes left for the class. So let's stop over here only. In the tomorrow's class we will be starting with next topic, that is purporting your on string. That is, purporting means working on the string, how string will be used. So let's stop over here only. Now if you have any doubts about the array, then please ask the doubt and I will answer you. In the tomorrow's class I will be starting your next topic, next chapter, that is chapter number 9, that is purporting on the string. So thanks a lot everyone for today's session. Now if any doubts, then please text the doubts. Okay, thanks a lot everyone. Bye bye.